Hello, ladies and gentlemen. Today we're going to be talking about box and whisker plots. Make sure you write down your objective. It says, I will be able to read and interpret a box and whisker plot. Okay? Now, for just a moment, I'm going to do a little analogy because I want you to understand how simple box and whisker plots can really be. Okay? What a box and whisker plot reminds me of is a sandwich, okay? More specifically, it reminds me of splitting up a sandwich. Okay, let me show you what I mean. Let's say you have this entire sub sandwich to yourself, and your best friend walks over and they would like some of your sandwich. So you're gonna be a nice friend and you are gonna split this sandwich in half. That's the first thing you're gonna do, okay? So now you've created two halves. You have the first half of the sandwich, and you have the second half of the sandwich. Now let's just say two more friends come up to you guys and they say, hey, I'd like some of this sandwich as well. Again, you guys are going to be nice friends, so you're going to split your half in half and your friend's going to split their half in half. So if you notice, I just created 4 equal sections. Each section represents 25% of the original sandwich. So we're basically going to be doing the same thing, except we're doing this with numerical data. Okay, we're taking numbers and we're finding the middle of those numbers. And then we're finding the middle of the first half and the middle of the last half. So let's look at our definition for box and whisker plot. So it's a graph that displays the centers and the range of data distribution on a number line. Now guys, I'm going to go through the definitions part of this fast. I want you to pause so that you can write these down, and then I want you to resume the video when you're done writing down your definitions. Okay, so here I have this picture again. I just had on the last page. I want you to notice there is, the reason we call this a box and whisker plot, okay, this part right here is what most people refer to as the box. It's just a rectangle. There's always going to be a line going through that rectangle. Okay, so that's our box. And then you're going to have 2 lines extending from either side of the box. Those are what we call the whiskers. What I want you to notice is, just like that sub sandwich example, each section of this box and whisker plot represents 25% or 1/4 of the data. Okay, now these sections have a specific name. They are called quartiles. Make sure you write this down. There are 4 equal sections and they are called quartiles. Each one represents 25% of the data. Okay, again, like I said, I'm going to go fast through these definitions, so pause this. Now, this page you're definitely going to want to pause so you can get all of this information written down. I'm going to be on this page for a little while, but you're probably going to need to pause. I want you to draw this box and whisker plot. Okay, it's not that difficult. You can draw it. It's just a rectangle and 2 lines extending out. Okay, and I want you to write off to the side what each part of the box and whisker plot represents. There's going to be 5 total parts, okay? There's this value here, there's this part of the box, this part of the box, this part of the box, and then this last value here. So there's a total of 5 parts that you need to identify. Even though there's only 4 sections, there's going to be 5 pieces that you need to identify. So this value here represents the lowest value in my data set. Let me just give you a basic example. Okay, so I have a list of numbers. What's the lowest value? The lowest value is 1. So that would be an example of the lowest value. Sometimes they call it the lower extreme. Okay, now, what does this section represent? This section represents the middle of the first half. Okay, so first thing I'm going to do when I look at my list of numbers is split it in half. There's the middle. And then I'm going to take the first half and I'm going to split it in half. And the back half, I'm going to split that in half as well. So this 2 is represented right there. Okay, that is the middle of the first half. Okay, this 4, which is represented right there, is what we call the median. It is the middle of all the numbers. And then this 6, it's right there. That's the middle of the back half. Now these 2 have special names. This is called the lower quartile, and this is called the upper quartile. Those are just those other slices. Let me go back. Those are just the other slices I had to do in the sandwich when my other friends came along, okay? So these are called your lower quartile and your upper quartile. And this right here, the very, very middle of all of it, is the median. Okay, then of course you have a dot out here. The line's going to extend out to that value. That represents your highest value. Okay, so it does say draw this. So if you're not done drawing it, go ahead and finish that up. Make sure that you have all this drawn. There is also this part down here which is very important. If you want to know something called the interquartile range, okay, that's the difference between the two quartiles. So I would just subtract the upper quartile minus the lower quartile. Okay, so we're going to do an example. I have a list of test scores, and I want you to find these. I want you to find the lower extreme, which is the lowest value, the lower quartile, the median, upper quartile, and the upper extreme. Okay, first thing I'm going to do, I'm going to put this list of numbers in order. So I'm going to start with the smallest number up here, the smallest test score, which is a 67. 68 is the next. And make sure I'm including them all. 71, 73, 76, just putting them in order. 82, 84, 90, and 92. Okay, so you can start with whichever one of these values you want to first. The first is the lower extreme. So just tell me, what's the lowest number? What was the lowest test score? Well, that's easy. That was 67. Okay. While we're at it, what was the upper extreme? What was the highest test score? 92. See how easy that was? Okay, now I want to know, what's the median? What's the very middle number? So if I count, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 scores. So if I count in 1, 2, 3, 4, the fifth number is in the middle, okay? Notice I have half of the data values in front and half of the data values behind. So the median is 76. Now looking at the first half of numbers, okay, I need to split this in half also, but there's actually two numbers in the middle. So guys, what I'm going to do if there's two numbers in the middle, sometimes this is going to happen, is you need to take the average of those two. And the average of these two, I'm going to go ahead and average them for you guys. It's going to be 69.5. Okay, so this was the middle of the first half, okay? So this was like the first half of the sandwich that I split down the middle. Okay, now I'm going to do the same thing back here. I'm going to split this in half. But again, there's two numbers in the middle. So I'm going to have to find the average of those two numbers, which really is just adding them up and dividing by 2. So that's going to be 87. So what you have just found is all 5 parts that would compose the box and whisker plot. Okay, you found all 5 values. Lower extreme, lower quartile, median, upper quartile, upper extreme. Okay, now the last example we're going to do, we're going to read this box and whisker plot. So part A says, what percent of players weigh over 220 pounds? Okay, so if I look on my number line, 220 pounds is right about here. And what is this part of the box called? That's the median. So what does that mean? That's like when I first split the sandwich in half. That means that half of the people weigh over 220 and half of the people weigh under 220. So when it says what percent weigh over 220, that's going to be half, which is 50%. What is the range of players' weights? Okay, well, range, if you recall, is the difference between the highest and the lowest. So I'm going to take the highest value, which I'm going to estimate to be about 310, and the lowest value, which is about 160, and I'm going to subtract those. That's going to get me 150. So to answer the question, what is the range of the player's weights? 150 pounds is the range. What is the most that a player weighs? Okay, well, where are you going to find that on your box and whisker plot? You're going to find that over here. This is your upper extreme. So that would be 310 pounds. And then lastly, what percent of players are less than 195? Okay, so here's 195. what percent is this section representing? Remember, each section should represent 25%. So that is going to be 25%. I'm not going to give you an on your own example. I know you guys are disappointed. This is the end of the video. Please make sure you took very good notes.